Great. So let's start. I would like to start with one use case. So imagine the patients with kidney dysfunctions like chronic kidney disease or patient after kidney transplantation. So these kidney dysfunctions cause accumulation of toxin in urine. This in turn disrupts metabolic processes, especially in the brain. And then this organized contamination causes emotional distress or bipolarity. So if we know emotional states of such patients, we would be able to help them actually much faster or more efficient. So the main question is, how can we recognize what they feel? So, oh, sorry, it is this screen. It's about this kidney case. So what can we do? We can, the best maybe solution would be a monitor on our forehead displaying our current emotions, but of course it is not a very practical solution. So we need something much more comfortable and useful, something we can utilize in our everyday life scenarios. So there are many solutions for emotion recognition based on facial or audio processing. Some of them were addressed by our first speaker, Daniel. But it is not always possible to obtain such face or speech recordings. So in our opinion, the best solution are pervasive wearables operating on physiological and behavioral signals and sensors, since they can be available all the time. So our response to that is a systematic literature review. So we look at the literature and ask ourselves a question: can wearables be used to identify emotions in our everyday life? So what literature says about this? So we analyze a couple thousands of papers, out of which 35 were actually included into our survey, and only 3 of them were field studies, which was very surprising for us. In general, we can distinguish 7 crucial components of emotion recognition with wearables. So let's go over each of them. So the first one is our emotional models. So there are lots of them in the literature. In general, we can distinguish either categorical or dimensional models. Amongst the first ones, there are well-known Ekman's or Plachik categories, and they were pretty often used, but not so much. And what was also surprising us, over half of the studies use their own categories. Also, own categories we could see in the previous presentation by our great ladies. So it makes these own categories make all this research incomparable with each other. So dimensional approaches used 1, 2, or 3 dimensions. They usually had discrete values, also like in the previous presentation. They're like, for example, low arousal, high arousal, positive valence, and negative valence, like happy and sad. So it is quite simple, these categories or even dimensions. So the first main problem with the emotional models is no single commonly agreed and used model. Secondly, dimensional models are actually treated as categorical ones. So they are formally dimensional, but practically they are picked up some categories and analyzed within these categories. Thirdly, emotional model selection determines classification model. So we can have simple binary classification like happy, sad. We can have multi-class classification with multiple categories, and multi-label classification, which is, to our mind, the future, but very rarely considered in the literature. Because, why? Because it is tough. And of course, we can have regression for the dimensional continuous values, which were actually not used. It is more theoretical than practically applied. Participants, let's go further. In the literature, we can consider age, gender, and personality, which commonly is agreed that it influences on our emotional experience. It is also impacted by our current historical medications and treatment history. Depression, also mentioned before, excessive sweating, which impacts on GSR, it is readings and so on. So addictions refer to other factors like cigarettes, tobacco, alcohol, coffee, which was consumed just before recording of our by our sensors. All of them can increase heart rate and heart dependent signals. And the problems and challenges. So having only few participants, we cannot generalize the solutions. So large-scale studies are absolutely necessary here. Since everyone and every human actually is slightly different, we should apply context and personalized solutions, and it is the future. So actually only one paper touched a little bit these personalization issues. Stimuli. In the researcher prefers stimuli that have been annotated before. It is the kind of ground truth, the gold standards. For example, funny or sad videos, or various multimedia like photos and music. And it was used in about 70% of all studies. Some researchers tried to stimulate real life scenarios. It was very interesting for us, such as playing computer games, solving math problems, learning, or walking around the city. So one of these three studies applied to field studies was walking on specific roads around the city in Nottingham in the UK. Another one was regular life. So the participants were wearing device for 6 hours. And yet another was wearing Empatica. It is the device, a pretty well-known device, for 3 weeks, but it was the only one here. So trying to conclude this issue, so real life scenario, it is a really great challenge for the future studies and the future implementations. Let's go further. Self-assessment. Having the devices and signals from them, we need to collect ground truth. And this ground truth for models are self-assessment, also mentioned before by our ladies. They are delivered by participant in the most common procedure. So here we have an examples for that. This self-assessment reflects perception of these emotions by participants. It is very important because it is how do they really perceive their emotional state. And they directly result from the selected emotional models mentioned before. So if you have 3 emotion categories or 6, it is directly impacts on these questionnaires. So the most common approach are self-assessment mannequin, it is this first one, Likert scale, this is the second one, or predefined list, it is here a little bit below. So some of the researchers have not mentioned what they have used. So concluding, self-assessments are quite subjective. So it is, as I said before, it is perception of our emotional states, and it differs for each of us. It is also impacted, can be impacted by culture. Also, this issue was raised by the others, by the previous presenters, by the culture community we live in. Also by the language plays quite important role here. So we express our self-assessment by means of language, so like happiness. Finally, everything strongly depends on the emotional model we utilize. Sensors and signals within wearables. So there are devices placed or that are put on our forehead to monitor the EEG signals like Muse or Emotive. There are also chest straps we can place on our chest to monitor ECG signals like Polar H10, or smart rings we can put on our fingers like Oura Ring, which are recently being used in California to try to detect the coronavirus infected people. But the most common and most promising are wristbands or smartwatches, like this one. Oh, it's here. I can show you. Here you can see the sensors. These are these LEDs. Then they use this sensor are photoplethysmography, these LEDs. Besides, they can have sensor that monitor galvanic skin responses. It is GSR or EDA, electrodermal activity, and body temperature. So these 3 the signals are crucial for the emotion recognition using this kind of devices like smartwatches. From these rough signals, if we have them available, we can derive the new ones like blood volume pulse, heart rate mentioned before, heart rate variability. So this is the intervals between the peaks in our heart activity. Okay, here you can have, you can see some devices used in the research. Some of them are quite old. The most popular is Empaticus, is this top left one, and used in pretty many, developed partially by the startup established at MIT, and but settled in Italy right now. There are also some not off-the-shelf devices that you cannot buy. So it is not commercial devices used by some of the researchers or groups, and you cannot replace their studies. This Microsoft band is not supported anymore by Microsoft. Samsung Gear S was replaced by Samsung Galaxy Watch. It is that one. Oh, you can see this. Yeah. And pretty many, as I said, pretty many use their own. There are dozens of new devices released every year. So actually, what it was also our discovery that scientific studies are a bit behind the equipment releases to the market. Concluding this, this sensor and signal issues. So the vital question is whether to use dedicated or commercial devices, off-the-shelf ones. And this off-the-shelf facilitate replicability of our research. Many products lock signals from their wearables, so we cannot actually access them, and we cannot perform our own analysis using the signals. So it is, they have the sensors, but they do not provide accessibility to the data, to the signals, to the rough data. Besides, a sensor can provide signals of various quality, like different sampling frequency, and it also matters. And another problem is training the users how to wear, charge, and operate wearables, which is significant if you would like to run large-scale studies. Signal processing, hopefully very shortly, because it is the big issue and big domain. So they consist of several steps, this processing. The first one is pre-processing, and some typical steps within. Pre-processing are removal of outliers, artifact removal, interpolation of deleted samples, normalization, standardization, filtration, and typical filtration of signals like low pass, band pass, or notch, or median filters, which is or drift removal seen here on the bottom right chart. Another one, it is extraction of features, which in case of the signals could be time domain features based on signal morphology like amplitude, extreme intervals, and so on. They are quite popular in the literature. Besides, we have frequency domain features like power spectral density or frequency spectrum. It is shown here. We can have also pretty well-known time frequency or time scale domain. It is wavelet transform or short time Fourier transform. Fourier transform is not used pretty often, but wavelet transform quite good, especially the discrete implementation. Besides, we can have statistical and or nonlinear features. I will skip them. What are the problems with these signals? So different signals require different features. So sometimes different window size, etc. It leads to us to the multimodal approaches, which in general are the future of emotion recognition. That is our observation. So assuming that that also the deep learning is the future, together with these multimodal approaches, we also need to adjust input preparation for these deep learning models. One of the examples for that purpose are deep learning methods for feature definition using embedding, which is based on the representation learning with auto-transformers or backpropagation, which is combines entire neural networks with the input. Besides, we have the great challenge with developing features and methods that would respect individual differences between humans. It is also the future and challenge, because every one of us is slightly different, and we should probably, I mean, in terms of their physiology and also behavior. So we should respect this in our analysis. Models and validation. Let's go further. Different studies used either a single or multiple reasoning models, classifiers. Among them, SVM support vector machines are quite popular, 1/3 of the studies. Besides ADABUS, linear discriminant analysis, random forest, and KNN were used, but there were single papers about this. Neural networks were used relatively in few studies, only 15%, but overall they gain more and more attention in the newer research. Deep neural networks are used in only 4 papers, which was surprising us. 2 of them use convolutional neural networks, but only 2 papers use LSTM. It is, or bidirectional LSTM, which is the long short-term memory architecture. It is suitable for sequential nature, and this sequential nature is typical for signals or text. What are other issues related to models? So only 2 studies refer to imbalanced data. It is crucial because we can have more cases on a given class, like 90% of happiness and only 10% for sadness. So it is highly imbalanced, and we should apply appropriate method for that. A validation of adjustment of models were performed in only half of the papers, and only 2 studies validated the result with psychologists, which is very few, and only a few papers around statistical tests on the results. And as I mentioned before, only 1 paper touched personalization issues. What are the in general problems with the models and validation? So mentioned before, imbalanced classes. It is the huge problem, pretty often not addressed at all. Multi-label classification is a great challenge, not touched in many of the studies, since it requires much more samples, and reasoning quality is often lower than in case of the binary or multi-class classification. So if you would like to have higher quality, so people tend to avoid multi-label classification. So deep learning architecture is also the great opportunity, but also the great challenge. So since we expect multimodal approaches, we also need appropriate architecture for that, and that would enable co-learning between modalities, for example, different fusion strategies between modalities, and also different approaches for dealing with the input preparation. As seen here, it is like shared bottom layer architecture. It is used by YouTube for recommender system. It is the picture from slightly another paper. And efficiency is yet another problem and challenge, since if you would like to perform processing on smartwatches, on smartphone, efficiency can matter. Otherwise, of course, we can do this in the cloud, but it is not always possible. Trying to summarize, first of all, there are few studies carried out in the field, which means that there's a relatively, well, it's a huge gap in research for real life scenarios. There's actually no research which could be seen as comprehensive with respect to all the research design state mentioned before, that would, for example, respect imbalanced data problem, optimize machine learning parameters and hyperparameters, and have the ethical committee approval, which is also not addressed by many of the researchers, which is also strange. Simple affective models like low arousal, high arousal, or no stress, low stress, high stress were commonly explored in the literature. Why? Because it is easy. They relatively easy correlate with galvanic skin response, which is on our skin. It is GSR, and the BVP, it is blood volume pulse, are relatively highly correlated with these simple models. But simultaneously, most of the paper use their own emotional categories that makes any comparative study actually impossible. Lack of access to rough signals, also to source code, do not help either. Only 2 papers publish their data and source code, which is, well, it is strange. So our observation is that in general, emotions are really much more complex and require more sophisticated emotional models. Here in multidimensional models, so if you would like to apply these multidimensional models, we should strive forward, apply multi-label classification, which was not used in any paper. So from our point of view and our observation, deep learning appears to be the most promising direction, and we need to find effective way to implement this. Very shortly, applications. So some of them were mentioned in different papers. It is the set of that are related to healthcare, human-computer interaction, interfaces, and some others. And I would like also to promote our web service that we have developed using the results of our studies. So we want to end up this with 1 or 2 several articles as well. One of them was already published. So we'll continue this systematic literature review later on. So you can contribute. And our current work focus on deep learning studies and knowledge platform. Here you can have the team. I will clip it. And our recent papers on this, one of them was presented and published at the Pervasive Computing Conference a month ago at the Motion Aware workshop, and yet another is in reviews to the International Symposium on Wearable Computing. So take a word message. Emotion recognition with wearables is the future of personalized affective computing. So that's our message. More field studies are needed, and every stage mentioned by me is the space for significant improvement to achieve better emotion recognition level. Thank you very much.
So we do have one question in the Q&A. Do you want to take a look there?
Yes, give me a second. I need to.
I'll read it from Yasin Benajibach, who asks, did you do any sanity check steps to make sure the model is generalizing well?
So it is the matter of, so we have analyzed, so what I have presented, it is the analysis of the literature. So what the others did. So very little statistical tests have been performed in the literature. But if I would like to say about our studies, yes, so we do this statistical test on which are related to this generalization issues. So for example, if you look at this cross-validation methods, it is one of the typical methods. How can we evaluate the generalization ability of the model?